Number 5, finding the sample standard deviation. Keyword sample, it's different slightly than the population standard deviation. So if you just have a sample of data, you want to use the formula here. It's on page 145. And the difference is instead of dividing by n, you divide by n minus 1. If you look at the numerator, the top part here, you take each data value and see how far away it is from the mean. Subtract the mean. Then we're going to square those results and add them all up. And you have to square because if you don't square, when you add them all up, it'll always add up to 0. Because the data values that are less than the mean will be negative, and the ones bigger than the mean will be positive when you subtract here. And so those negatives and positives would cancel out, and you would always get 0. But when you square it, it avoids that problem of adding up to 0. And that's why we take the square root at the end. The square and the square root cancel each other out. So because we square, we have to take the square root. But yeah, so one more time, this formula, really understand what we're trying to do is just see and get an average basically of how far away every data value is from the mean. We're going to see how far away they are, add them all up, and then divide by one less than the number there are. So let's look at the numbers. Actually, I've copied them here into Excel. Start by finding the mean. So I just use the average in Excel to get the mean of this data. And then the formula said take each value, subtract the mean. Here I took each data value and subtracted it from that 28.7 value of the mean. And then the formula said for each of those differences from the mean, square it. So then I just squared these results here. And the formula says add all those squared values together. So I summed all those up. And then the formula says now divide by n minus 1. So n is how many data values are. There are 10. So I divide by 9 here. This sum divided by 9. And finally, since we've reduced everything inside, now we can take the square root. And you take the square root and you get this value. So that's how you would work it out bit by hand, follow the formula. But once you understand what the formula is trying to measure, you're taking each data value and seeing how far away is it from the mean. And we're going to try to get just an average value of how far away the data values are from the mean. It helps us understand how spread out the data is. When you understand that you don't go through all these steps every time, let Excel do the background complicated work for you. If you just type in standard deviation and then .s for sample and select your data, it'll calculate the value for you right away. Looking at number 7, making confetti, we have 3 different ingredients here, and we're trying to find the cost per pound. So we need to know the total cost and the total weight, the total amount of pounds there are, and then we'll be able to find the cost per pound. So I made a table in Excel of our 3 ingredients and how many pounds of each of those ingredients and the cost of each of those ingredients. So the problem gave you all this information. And then so your total pounds, you just add up the 3 individual ingredients. We had 12 pounds. And to get the total cost, you would need to multiply here. So if we had 4 pounds at this price, that's the total cost for the hearts. And do the same thing for the stars, for the coils. You get the prices of each ingredient, add them all up. So if we spent that much money on that many pounds, we can divide that out and get the cost per pound. For number 8, the box plot always has a 5-number summary, and it gives you a kind of an overview of the data. So you don't know what all the data was for Professor Deng's class here, but you have this summary that gives you a pretty good overview. And the smallest number is the lowest score for the class, and that's where you want your whisker to end at. These lines are called whiskers that come out from the box. So it should end at 58, and this is the best score in the class, 96. So this whisker should go up to 96. So just from that, you may be able to figure out, or at least exclude some of the wrong results. Make sure the whiskers end at the lowest and the highest. And then these 3 numbers tell you about the box, which the what we call the first quartile, the 25% of people are below this mark. So from 25% up to 75% of the class falls within the box. So that's what this box plot's trying to show you, is that big chunk of people between 25% and 75%, they're all within this box. And then the whisker is showing you the bottom 25%, and then here this whisker shows you the top 25%. So the box then starts at 65 and it ends at 88. And the median, the score exactly in the middle, is the line you draw in the box. For number 9 here, we don't have that 5-number summary, we just have the raw data. Let me pull that into StatCrunch. So open in StatCrunch. So we can do stats here, our summary stats. I'll just do one column at a time. Let's look at the name brand. If you just hit compute, so I'm not changing anything, compute gives you a bunch of data, everything selected. So it gives you the median, the min, the max, the quartile 1, which is where that box will start, the 25% mark, and quartile 3, where that box will end, the 75% mark. So that's your 5-number summary right here. Ignore the range, but the min, quartile 1, the median, quartile 3, and then the max. So if you just put those in numerical order, you have your 5-number summary in order. So it looks like 22, 23, 26, 29, 35, which you find the box and that lines up with starting at that first number. The box goes to those middle 3 numbers, and then it ends at the last one, the max. And do the same thing for the store brand. And then does there appear to be a difference in the number of chips per cookie? And if you look at our 2 box and whisker plots here, the name brand's box is just shifted a little higher than the store brand. So the majority of cookies, the 25% up to 75% of their cookies all have more chocolate chips than the store brand does. And our low end, the cookies that really don't have a lot, doesn't go down near as far as the store brand. So the store brand's going to have a bunch of cookies with hardly any chocolate chips. So just because this whole box and whisker is shifted higher, it does appear the name brand has more chips per cookie. I think you got this next part right. More consistent chips. Yeah, the name brand's more consistent, just because the whiskers are shorter here. If you look at the store brand, there's some that have not very many chocolate chips at all, and this whisker goes out quite a bit too with a lot. But here the box is a little smaller and the whiskers don't go as long, so yeah, it's more consistent. For number 10 here, they give you a value for R. Notice it's negative. And before I say anything else, let's look at the pictures here on page 194. Positives are going to have an upward slope, and like these 3. Negatives will have a downward slope like these 3. So you could throw anything that looks positive is definitely wrong. So it's going to have a downward slope. And this is not very close to 0 or to 1. If it's really, really close to 1, that means it's perfect. A perfect correlation, so it'd be a perfect straight line. And if it's really, really, really close to 0, there's not really a good line you can draw at all. So something like this would be close to 0. So if it's in between there, the closer it is to 1, the closer it's going to be to straight. The closer it is to 0, the more it starts looking. And you can see -1, -0.9 still looks kind of like a line. -0.4, you can make out a line, but it's not near as good as these 2. And then once you get even closer to 0, like which way do you even draw the line here? The dots are all over the place. So with -0.5, a little bit over 0.5, it's going to look fairly good like a line, fairly, but I mean not really solid like a line like this. This would be really close to 1. And so I can see a little confusion here between these. This one's still, this is probably exactly 1. This one's really close to 1 like we had here with negative 0.9. If you're down at negative 0.5, you're going to be less linear because you're getting closer to 0. So this is too close to perfect still for a negative 0.5. This one's starting to get more spread out.